There is a habit sitting in almost every kitchen in the world right now, so ordinary that nobody thinks twice about it. Leftovers, sealed in a container, shoved into the fridge after dinner, then pulled back out the next day and reheated without a second thought. It feels harmless. It feels responsible even, like you are saving money and reducing waste. But there is a small, uncomfortable body of research that has been quietly building for years, and it points to something most people have never been told. A handful of specific foods, when reheated, do not just lose flavor or texture. Under certain conditions, they can undergo chemical changes that researchers studying cancer risk have flagged as worth paying attention to. Not fear-mongering, not vague internet rumors, but real mechanisms with real names, studied in real labs. Today, we are going through 4 of them, and by the end, you will understand exactly what is happening at the molecular level every time you hit reheat, and which foods deserve a second look before they go back into your microwave. Before we get into the 4 foods that actually deserve your attention, it is worth clearing something up, because the internet has muddied this topic badly over the years. You have probably seen the viral claims. Never reheat rice, it will poison you instantly. Never reheat eggs, they turn toxic. Never reheat mushrooms. Never reheat chicken. Never reheat this. Never reheat that. Until the list becomes so long it stops meaning anything at all. Most of those claims are either wildly exaggerated or based on a misunderstanding of a real but narrow issue. Rice, for example, does carry a genuine food safety risk when reheated, but it is not really about the reheating step at all. It is about a bacterium called Bacillus cereus, which can survive cooking as a spore and then multiply rapidly if cooked rice is left sitting at room temperature for too long before refrigeration. Reheating it afterward does not fix that problem, because the toxin the bacteria produce can survive the heat even after the bacteria themselves are killed. That is a real issue, but it is a storage problem, not strictly a cancer-related reheating problem, and it deserves its own conversation. Eggs and mushrooms, on the other hand, despite the popular warnings, do not have solid scientific backing behind the specific claims that circulate about them. So we are setting those aside today, because the goal here is authenticity, not just repeating whatever gets the most views. The 4 foods we are covering are the ones with an actual, traceable chemical mechanism, connecting reheating specifically to cancer research, not general food poisoning risk. Let's start with the one that catches almost everyone off guard, because it seems like the last food anyone would worry about. Processed and cured meats. Bacon, hot dogs, deli ham, sausage, the kind of food most of us grew up eating without a second thought. These meats are cured using nitrites, a preservative that has been used for centuries because it does an excellent job of preventing bacterial growth, particularly the bacteria responsible for botulism. On its own, at normal cooking temperatures, this is a manageable trade-off. But here is where reheating changes the equation. When cured meat is exposed to high heat, especially the kind of high, dry heat you get from frying, grilling, or blasting something in a hot pan to crisp it back up, the nitrites in that meat can react with naturally occurring amino compounds in the meat itself. This reaction produces a class of chemical compounds called nitrosamines. Nitrosamines are not some fringe concern. They have been studied extensively, and a number of them are classified by major health organizations as probable or possible human carcinogens based on both animal studies and observational data in humans. The International Agency for Research on Cancer has already classified processed meat as a Group 1 carcinogen, meaning there is strong evidence linking regular consumption to increased colorectal cancer risk, largely tied to this exact nitrosamine pathway. What makes reheating specifically relevant here is that the first round of cooking already creates some nitrosamine formation, and a second round of high-heat reheating, particularly frying leftover bacon or crisping up a hot dog in a pan, can push that formation even higher. This does not mean one reheated hot dog is a health emergency. It means that the combination of cured meat, high dry heat, and repeated exposure is a pattern worth being aware of, especially for people who eat processed meat regularly and tend to reheat it the same way every time, at high heat until it crisps. Food scientists have actually measured this effect directly in controlled studies, comparing nitrosamine levels in freshly cooked bacon against bacon that has been fried once, refrigerated, and then fried again to crisp it back up. The general pattern that emerges is fairly consistent. The second high heat exposure tends to push nitrosamine concentrations higher than the first cooking alone produced. It is not an enormous multiplier. And it is not the same as, say, deliberately consuming a known toxin, but it is measurable and it is directional. More heat exposure, applied more times to a food that already contains the chemical precursors, tends to produce more of the compound in question. That is really the entire principle running underneath this whole video, and cured meat is simply the clearest, best documented example of it. The second food on this list surprises people because it seems like the picture of health: spinach, and other nitrate-rich leafy greens like beet greens, arugula, and to a lesser extent, celery and beets themselves. These vegetables are naturally high in nitrates, which is actually part of why they are considered beneficial in the first place, since dietary nitrates get converted in the body into nitric oxide, a compound that helps blood vessels relax and improves circulation. The problem is not the nitrate itself. The problem is what can happen to that nitrate when cooked greens sit around, particularly at room temperature, before being reheated. When cooked spinach is left out, especially for more than an hour or two, certain bacteria that may be present can convert those naturally occurring nitrates into nitrites. This is a well-documented food safety concern, serious enough that several European food safety agencies have issued specific guidance advising against reheating spinach more than once, and recommending it not be reheated at all for infants and young children, whose bodies are more vulnerable to nitrite exposure. Once those nitrites are present, reheating the spinach at high temperatures, particularly in combination with any protein in the same dish, creates the same nitrosamine-forming reaction we just talked about with cured meat. So the actual risk here is not eating spinach. It is eating spinach that was cooked, left sitting out for an extended period, and then reheated, especially more than once. The fix is almost embarrassingly simple. Refrigerate cooked greens quickly, within an hour if possible, and try to only reheat them once. This is also a good moment to mention that the same nitrate-to-nitrite concern extends, to varying degrees, to other vegetables that tend to sit in family fridges for days at a time. Beetroot, celery, and to a lesser extent, certain root vegetables all carry naturally higher nitrate content than most produce, which under normal conditions is actually a nutritional advantage, tied to those circulation benefits mentioned earlier. The concern only really surfaces when cooked portions of these vegetables are stored improperly, left out too long, or reheated multiple times in a row rather than eaten fresh or refrigerated promptly. It is a storage and handling issue layered on top of an otherwise healthy food, not a reason to avoid leafy greens or root vegetables altogether. Now, before we get to the third one, it is worth pointing out something these first two have in common, because it clarifies what is actually going on here. Neither bacon nor spinach is dangerous in its normal state. The danger, in both cases, comes from a specific combination of factors: naturally occurring or added nitrogen compounds, high heat, and time. Change any one of those variables and the risk changes dramatically. That pattern is going to show up again in the next two foods, and once you see it, you will start noticing it everywhere in your own kitchen. The third food is one almost nobody would think to question, because it feels like the definition of comfort food. Potatoes, specifically starchy preparations like French fries, hash browns, roasted potatoes, and baked potatoes that get crisped back up in a hot oven or air fryer the next day. The concern here involves a completely different chemical than nitrosamines. It is called acrylamide, and it forms through something known as the Maillard reaction, the same browning reaction responsible for the golden crust on toast, the crisp edge of a roasted potato, and the deep color of coffee. Acrylamide specifically forms when starchy foods are cooked at high temperatures, particularly through frying, roasting, or baking, and it forms in greater quantities the more browned or charred the food becomes. Acrylamide has been studied by the World Health Organization and multiple national food safety agencies, and animal studies have shown it can be carcinogenic at high doses, although the evidence in humans at typical dietary exposure levels is still considered less conclusive and remains an active area of research. Regulatory agencies in the European Union have taken it seriously, enough to set specific benchmark levels for acrylamide in commercial food products like potato chips and French fries, pushing manufacturers to adjust cooking processes to reduce it. Here is where reheating comes in. Reheating already cooked starchy foods at high heat, especially crisping them up a second time in an oven, toaster oven, or air fryer, can increase acrylamide formation beyond what was already created during the initial cooking. The darker and crispier the reheated result, the higher the acrylamide content tends to be. This does not mean you need to eat pale, soggy leftover fries. It means that blasting yesterday's potatoes at maximum heat until they are deeply browned and crunchy is doing something more than just improving texture. It is worth noting that acrylamide is not unique to potatoes. It shows up in any starchy food pushed to high, dry heat, including toast, coffee, and baked goods, which is part of why food scientists study it so broadly rather than treating it as a potato-specific problem. Potatoes simply tend to be the food most people reheat aggressively and repeatedly, often in an air fryer specifically because it produces that satisfying crunch, which is exactly the cooking method most associated with higher acrylamide formation. Choosing a gentler reheating method, even if it sacrifices a bit of crispness, is a small trade that meaningfully reduces this particular exposure. The fourth and final food is the one that tends to generate the most disagreement, because it involves something almost every kitchen has, and most people would never think twice about reusing. Cooking oil, particularly oil that has already been used once for frying and then reheated for a second or third round of cooking. This is common in households that fry food regularly and simply strain and reuse the oil to save money, and it is even more common in commercial kitchens and street food stalls where the same oil might be used dozens of times in a single day. When oil is heated, especially to high frying temperatures, and then cooled and reheated again, it undergoes a process called oxidation. Repeated heating breaks down the fat molecules in the oil, producing a range of byproducts, including aldehydes, a class of compounds that some studies have linked to increased oxidative stress and inflammation in the body when consumed regularly over time. Research out of multiple food science departments has specifically looked at reused vegetable oils, particularly those high in polyunsaturated fats, and found that repeated heating cycles significantly increase the concentration of these harmful breakdown products, with some studies pointing to potential links between chronic consumption of heavily reused frying oil and increased cancer risk. Though this research is still developing and the strongest evidence so far comes from populations with very high regular exposure, such as workers in commercial fried food production. For the average home cook, the concern scales with how many times the same batch of oil gets reused and how hot it was pushed each time, particularly if the oil starts to smoke, darken significantly, or develop a rancid smell, all of which are signs that oxidation has already progressed significantly. Not all oils break down at the same rate either, which matters if you are trying to reduce this particular risk without giving up frying altogether. Oils high in polyunsaturated fat, like many common vegetable and seed oils, tend to oxidize faster under repeated high heat than oils higher in monounsaturated or saturated fat, such as olive oil or avocado oil, which hold up somewhat better across multiple uses. This does not mean any oil can be reused indefinitely. It simply means the choice of oil, combined with how many times it gets reheated and how hot it gets pushed each time, together determine how much oxidative byproduct actually ends up in the food it cooks. So here's what all four of these foods actually have in common once you step back and look at the full picture. It is never really about the food itself in its fresh, normal state. Bacon is not inherently dangerous. Spinach is famously good for you. Potatoes are a staple in diets all over the world. Cooking oil is a basic kitchen tool. What changes the equation, in every single case, is the combination of specific chemical precursors already present in the food, high heat applied a second or third time, and in some cases, time spent sitting out before that reheating happens. Understanding that pattern is far more useful than simply memorizing a list of foods to fear, because it means you can make small, practical adjustments rather than cutting entire food groups out of your life. For cured meats, that might mean reheating gently, using lower heat and shorter cooking times instead of crisping them until they are charred. For leafy greens like spinach, it means refrigerating leftovers quickly and limiting reheating to a single round, rather than repeatedly warming the same batch over several days. For starchy foods like potatoes, it means accepting a slightly less crispy result when reheating, rather than pushing for maximum browning every single time. And for cooking oil, it means being more mindful about how many times the same oil gets reused, watching for the warning signs of smoke, dark color, or rancid smell, and replacing it sooner rather than stretching it as far as possible. Taken together, these four adjustments take almost no extra time and cost nothing beyond maybe replacing cooking oil a little more often than you currently do. That is really the most important thing to understand about all of this. Reducing exposure to these specific compounds is not about buying anything new, following a complicated protocol, or overhauling how you cook. It is about a handful of small timing and temperature decisions, repeated consistently, The same way the risk itself only becomes meaningful when the wrong choices are repeated consistently. None of this means reheated food is something to be afraid of. Humans have been reheating meals for as long as we have had fire, and the vast majority of leftovers, reheated the normal, occasional way most people actually eat, carry a negligible risk in the bigger picture of everything else that shapes long-term health. What this comes down to is pattern and frequency. A person who fries reused oil daily, reheats cured meat at high heat several times a week, and regularly rewarms days-old spinach is dealing with a meaningfully different level of exposure than someone who occasionally microwaves last night's dinner. The goal here is not perfection. It is awareness, so that the choices you make in your own kitchen are actually informed ones, rather than habits nobody ever explained the reasoning behind. It is worth remembering, too, that cancer risk is never determined by a single food, a single meal, or a single reheating session. It is built, gradually, out of thousands of small exposures and choices repeated over years and decades, layered on top of genetics, environment, and countless other factors entirely outside anyone's control. Knowing which foods carry these specific chemical risk factors when reheated is not about triggering anxiety over dinner. It is about giving you the same information researchers already have, so you can make small adjustments where they actually matter, without turning your kitchen into a source of stress. There is also something reassuring buried inside all of this, if you look at it the right way. Every single mechanism covered today, nitrosamine formation, acrylamide, oxidized oil, is influenced heavily by things you can actually control. This is not a genetic risk factor you inherited and cannot change. It is not an environmental exposure happening somewhere outside your house that you have no say over. It is happening in your own kitchen, shaped by your own choices about heat, timing, and storage, which means it is also one of the more directly modifiable pieces of your long-term cancer risk profile. Very few things in the entire conversation around cancer prevention are this concretely within a person's control, and that alone makes it worth paying attention to. Let's take a moment to walk through what an actually safer version of leftover night looks like, because knowing the risk is only useful if it translates into something you can actually do. Cool leftovers quickly instead of leaving them on the counter for hours, ideally getting anything perishable into the fridge within about 2 hours of cooking. When reheating cured meats, use a lower, gentler heat setting instead of maximizing crispiness, and avoid repeatedly reheating the same batch multiple times across several days. When reheating leafy greens like spinach, try to only do it once, and consider portioning meals in advance so you are not repeatedly rewarming the same container over and over. For starchy sides like potatoes, a slightly softer reheat in the microwave, rather than a second trip through the oven or air fryer at maximum heat, cuts down on additional browning. And for cooking oil, simply paying attention to how many times a batch has been reused, and replacing it once it starts to darken, smoke at lower temperatures than it used to, or smell even slightly off, removes most of the risk without requiring any real sacrifice. None of these adjustments cost anything or require giving up foods you enjoy. They are small shifts in timing and technique, the kind of thing that, once you know about it, becomes almost automatic within a week or two. That is really the whole point of understanding the science behind something like this. It is not about eliminating risk entirely, because that is neither realistic nor necessary. It is about recognizing which everyday habits are quietly working against you, and making the kind of small corrections that add up over years, the same way the risks themselves add up over years. If you learned something new here, hit subscribe, because there is a lot more research-backed insight like this coming, and you will not want to miss it.